Today, we're going to start talking a little bit about cutting threads by hand, not with a machine. We're just looking up in the machine, one of these machinist handbooks about threads and pitches and diameters. And that's really great when we're dealing with threads like a 1/4-20 bolt or 3/8-16, but us woodturners don't do that. What we tend to do is make a hole that's right for our project, and then we need to size the threads internally and externally. Here's a thread for cutting the male thread, which is generally on the outside of a tenon. Here's one for cutting the female component, which will be down generally inside of a hole. But to keep that from running, we need to cut a relief behind that so that we can get the tool out before it does damage. I'll show you that when we actually cut some threads. So they have a tool for cutting a relief behind that female thread. It's one brand. Crown has a set. This is a little thicker, but it's a two-piece set. And again, one for the external or male thread, one for the internal or the female thread. They don't have a tool to go with it to cut a relief, so I made one. And this goes back inside the hole, cuts a relief behind where the female thread would end up going. Another brand. The latest one to come out is this one from Carter & Sons. It has this ball on it, which I don't much care for, but again, there's your external for cutting the male. Here's the internal for cutting the female, and it's all on one tool, which makes it very convenient. Now, I haven't talked about pitch. This is a 16 TPI thread. These cut a thread with 16 threads per inch. The Sorby set I showed you earlier was a 20 TPI thread cutting set. So when you're buying your first set, go for something that has a finer tooth pattern rather than a coarse one. When you're cutting the threads, you run the lathe at some speed and you have to be able to follow that thread along. We'll show you all this in a few minutes. But the finer the thread, the easier it is for you to follow when you're first learning. 20 would be a great place to start. It seems like a coarser would be better, but it's not. It's the opposite way around. Most common use these days is about 16 TPI. So that's why Carter came out with this one at 16 threads per inch. Well, the other thing we have to do is we have to be able to thread the inside of this. That's with this tool. And then we have to thread the outside of the lid component, which will be done with this tool. The question is, why are these two diameters different? Well, I tried to explain that to you in a very short 3-minute graphic, which I'll run right now and then come back to you and show you how we actually measure those distances. I've created a drawing here to help you understand a little bit more about the relationship of diameter and pitch in cutting hand-cut threads, because us woodturners don't always turn something of a specific known given diameter. We have to be able to do some calculations. So this is a 24 teeth per inch threads, and we measure that across the top of the tooth on one side, exactly horizontally across the top of the next tooth. And so this is what the male thread might look like. Now the female thread is the exact opposite. It has to set down inside those threads, and so therefore it has to be cut a little bit smaller, so that when we cut off the material for the male threads, we're removing the outside, and we're cutting off the material for the female thread, removing the inside. So when they fit together, they look sort of like this. You see how the female thread in white has to sit down inside. So at the very end, what we end up having is a situation like this, where we have a pitch of two different diameters. We start with either the male or the female, and we have to cut the other one to match. So here's the trick. If you have a 16 TPI, then the pitch is a 1/16 of an inch. So if I cut my male thread first and measure its diameter, I then remove 1/16 inch from that measurement, and that's the diameter I need to start with to cut my matching female thread. Alternatively, if I did it the other direction, I would cut the female thread, measure its diameter, and then have to add a 1/16 of an inch to cut the matching male portion so that they interlace perfectly. Now, this is not going to be exactly accurate every time, but it's going to be a good close thing to start. I know there are devices on the market that will give you a way to measure that and then make that correction. But you can do it yourself with just a caliper and a little bit of math. 16 TPI means you have to add or subtract approximately a 1/16 of an inch. 8 TPI means you add or subtract approximately 1/8 of an inch. Hope this helps. Well, I hope that helped. Let me show you what that calibration tool was like, the one I had the picture of. It's made by Sorby. It's one of their accessories. Since one has to be a slightly different diameter than the other, this is the way the Sorby system works. This little knob allows me to set it for 10, 16, or 20 threads per inch. I'm going to set it for 16. And then it slides like this. So I'm going to measure the inside of my practice vessel here and get this dimension, and then I'm going to lock the calipers. And for the other piece, this will then allow me to size that. This one says it's just still a little bit too big. So I now know, in order to cut the male thread here that goes inside the female thread here, this should be that diameter to start. Or do it like I said with calipers. I take this measurement, whatever it is, and this is going to be 16 threads per inch. So the lid needs to be a 1/16 of an inch larger in diameter. So I take the calipers and I go, the 1/16 is 0.0625. I add that, 625, and then I size it to that. And as you can see, I still got to take some more off on either one. They both say the same thing. So that's about getting the sizes right before we cut the thread. The other thing that's important for you to know in making your boxes with cut threads is that you're going to have very poor success if you use soft or stringy woods. Maple is right on the ragged edge of almost too soft to cut and hold a good thread. I'm doing this out of Osage orange. It's a really hard wood. It's fairly dense, and I think it's going to cut a relatively good thread. I haven't done it. We'll find out. The other thing that always works is black wood, ebony, or boxwood. Boxwood is the traditional wood that was chosen for cutting threads. The reason is it's very dense, and when we cut across this end grain to create the threads, it's not going to chip out as much as other woods. Stringy woods like walnut just won't hold a thread. They'll tear. You think things like Wenge would be really good. It's hard, it's dense, but it's stringy, and it will tear. So play around, try different woods. If you're going to use a wood that's reasonably soft, you may want to saturate the surface with thin CA glue first to add some stiffness before you begin to cut the threads. Anyway, the idea is to buy the tools, to practice, and to develop a new mechanical skill that you can add to any of your projects. So, I guess it's time to go back to the lathe and show you how to cut the internal and the external threads. See you at the lathe. Okay, we're back at the lathe. This is a piece I had up on the table when we were talking a few minutes ago. But I put it back on the lathe. This is not a finished box. I've left a lot of mass down here for mass and support. And when I opened this up initially, I used a Forstner bit. And the reason was I wanted this edge in here as straight as I could get it.
And that did the job. I could use a straight edge, put it along there and see what that line is. It looks pretty straight. So that's what I want. It's hollowed out, it's undercut. So the idea of having a relief when I run the thread chaser in is not going to be a problem, because it's going to run into just air because this is undercut. I'm using a 16 TPI set of thread straight chasers that are from Crown, tell by the handles. I've set the lathe speed at its lowest speed range. In other words, the high torque range that you generally use for turning bowls and large pieces where we need the maximum amount of torque. It's like putting your car into first gear to climb a steep hill. It gives me more control and a lower RPM range. So I've set mine up for right at 300 RPM. Well, if you don't have a variable speed lathe, you may not be able to go that low. Most of the 10 and 12 inch belt driven lathes have a bottom speed of around 500 RPM. And that's the best you can do. The key is find a speed, generally a lowest setting that you can, and that's the speed you're going to do all your work at. I'm going to try to do all the cutting at 300 RPM so that I can get the rhythm going. And when I go from this piece to that thing that will be the top, I'll hopefully be able to use the same rhythm. I don't know. We haven't done this for a while. We'll see what happens. So what I'm going to do is cut the internal thread, or the female first in this case. But I have a square corner here, and I know what makes it easier is if I relieve that corner and slightly radius it. So I'm using the flat of a skew chisel to just radius that over a little bit. Now, I'm going to take my thread chaser. It goes flat on the tool rest. If your tool rest has dinks on it, bumps, you got to file them off first. This needs to move smoothly. This is like the smoothness you need for pen turning, except in spades. Even better. So I'm also going to check to make sure I'm at center line, and I look like it's very close, maybe just that much more. So what I'm going to do is I'm going to start here on this corner, and I'm going to get a thread started. And as that grabs the chaser and starts wanting to pull it in, I'll bring it around until we're doing that. In fact, I think maybe I'll go up a little faster. I just changed my mind. That's 360. It's still pretty slow. So, and you have to get that rhythm. Okay, I found a problem already. The thread chaser is so thick, for this small hole, the bottom edge is dragging. I can't use this chaser. So I'm going to go to one that's thinner, still 16 TPI. This is the Carter & Son tool. And it's going to cut, and the bottom edge will not drag on that opening. So the thickness of this is important also. That's going to work. All right, try it again with a different thread chaser. It's flat on the tool rest. There's the rhythm. There's my thread. Now I'm looking at to see if I wanted to go a little bit deeper, and I may go just a little bit deeper. The top of the thread is not coming to a sharp point. It's a little flat. Once you get the rhythm going and it starts dragging the chaser in, it's not much work. I like that. That's pretty good. So now let's take this off and put on the piece that's going to fit inside. It's an unshaped lid. That's okay, because once it's threaded on, I can screw it onto the box and shape the outside of the lid then. So I've just got it between the corners. And it's nice and snug. And we've taken that measurement, I believe, and we've determined set that out of the picture. And that should be our size, and it looks a little bit big. So I'm going to take my skew chisel and take just a bit off. And I'm again using it as a scraper. This time I want a little bit more RPMs. It's not squared in the chuck very well. I want it to run as true as I can. That's as good as we're going to get it. And it's oversized anyway, so it'll come down a little bit. That's about 500. All I want to do is to be sure this is flat. As you can tell, it wasn't. And again, I'm going to create slight chamfer on the end. I'll check and see. Well, that's awful close. That's close enough to work with. So now, if I run in with my thread chaser, like this, I'm going to run into that shoulder. And I need a relief behind there so that I can get my tool out without it bottoming and damaging something. So I'm going to cut a relief in here. This is for cutting inside. It doesn't work for cutting outside. So I think a parting tool will be the right tool to help me here. Found one in here. Now for demonstration purposes, that's a little wider than what I normally want it, but it's also not square. Use my parting tool to square that up. Okay, so this is going to be the inside of the lid, and if I'm going to do any work on that, I should probably do that right now. So I'm going to do just a little cleanup cut here. This is the inside of the lid. And if I don't do it now, I may never get back to it again. You can hear that it was, when I chucked it, it went off center a little bit. Okay, so now we're ready to do that thread cutting. And we're going to use this cutter. We're going to try to get right on center line. It looks pretty good, but I really would like that tool rest really straight across. And that's right at center line. Now, what speed did I have? 325, was it? There we go. So I'm going to do the same thing. I'm going to start here on the corner, get that thread dragging across there nicely. And my stopping is to be sure that tool rest is smooth. And in that area that I'm working, it's got to be like glass. That's much better. Let's try it left-handed. Get that rhythm. Those threads started. And let it pull you across. Nice looking threads. It's ebony, that's why. But I don't know if it fits, so we're going to have to approach this in steps. No, that's a little way too large. So what I can simply do is keep cutting the threads, and I'll eventually get down to the diameter I need. And I'm not working at this now, I'm letting the tool being pulled through the ebony because the threads are already cut. Now if you're way off, what you can easily do, and I am a little bit way off, you can actually come in here with your skew chisel and just flatten the top of these threads. And then continue to cut until it fits. Thread was still there, so I didn't have to start over again. And I'm going to keep doing this until it fits. And once it fits, we got a little bit more to go. So rather than do all that, I'll continue to cut this thing, and then I'm going to screw it on. This will go back into the chuck, the top will get screwed on, and this then becomes, in essence, the jam chuck for me to finish the outside of that lid. So I'll do that, take it off, and then guess how I'm going to finish the inside of this? I'm going to cut another jam chuck, screw this on here, finish the bottom. So those are the steps. And I'll complete this, and I'll put it in here, and we'll have a box to show you shortly. So on your box challenge, if you have a set of cutters, time to practice. Time to get a good hard wood, make your threads, make your lidded box. Remember the other two options, threads, chatterwork. By the way, this wood is going to be beautiful for chattering. Dense wood, solid grain, perfect for chatterwork. And then if you're going to use pigments, no, not dyes, paint. Paint. You can add some paint to your project, charter work, cut threads, any two of the three. So look forward to seeing your projects next month at the meeting. Work hard, stay safe, we'll see you soon. There we go.